As we continue our study in the unit of reactions in stoichiometry, we now turn our attention to the second of two videos on Learning Goal 5.2. This lesson will focus on success criteria C and D. Our 5.2 learning goal, I understand the limits of chemical reactions. The two success criteria that we will focus on here are success criteria C, I can determine and define the theoretical yield of a reaction, and success criterion D, I can determine the percent yield of a chemical reaction. So we'll start with a couple of definitions here, just some of those words that you saw in the success criteria. A theoretical yield, that's the term that we give to the maximum amount of product that can be produced by a given amount of reactants. What we want to understand is that all of our stoichiometry calculations that we've learned to do so far, those are all theoretical. So for example, if the question says we have X number of grams of some reactant and it asks us to determine what mass of a product can be produced, that mass is theoretical, meaning we would only get that mass if we were able to collect every single bit of the product and if the entirety of the reactant actually did react, meaning it was completely consumed. In reality, that usually doesn't happen. And so we call this a theoretical yield. The maximum that we can get that produced from a given amount of reactant. The actual yield is what you would think it would be based on the term. It is the amount of product that is actually produced or obtained in a chemical reaction. This cannot be calculated. You can't calculate what the actual yield is going to be. You just have to do the reaction and collect the product, measure its mass, and you know your actual yield. Or in the case of the problems that you're given to work here, you just have to be told what the actual yield is. There's no way of calculating what the actual yield is going to be. And then a percent yield. A percent yield is a way to measure our experimental efficiency, or how much of the reactant actually reacted. And it's simply a comparison of the actual and theoretical yields. Think of the theoretical yield as the total or the whole amount. The actual yield is the part that we collect. And so to turn that into a percentage, we just find the ratio between the actual and theoretical yield. And to turn it into a percentage, we just multiply by 100 as we do with any percent. So let's just jump right in here and see how we would go about determining a theoretical yield and a percent yield. What you'll find is the calculations themselves, the stoichiometry, is absolutely no different than what you've already learned how to do. So let's consider this reaction. We're reacting potassium chromate with silver nitrate to give silver chromate and potassium nitrate. And you can see the equation is already balanced there. So the question is, what is the theoretical yield of silver chromate if 0.500 grams of silver nitrate reacts with excess potassium chromate? Well, the fact that we're told that the potassium chromate is in excess, that tells us that the silver nitrate is limiting. So this 0.5 grams of silver nitrate, that's what will determine how much product can form. So that's what will determine our theoretical yield. So in other words, this is just a gram, mole, mole, gram problem that we've been doing for some time now. I want to know the mass of silver chromate I can get because the question asked me, what is the theoretical yield of silver chromate? I want to know what mass of silver chromate I can get from my 5 grams of silver nitrate. And I know that the silver nitrate's limiting because we're told we have excess potassium chromate. So just doing our gram, mole, mole, gram, converting from grams to moles of silver nitrate using the molar mass of 169.87 grams per mole. Now I can use my mole to mole ratio. You can see in the equation 2 moles of silver nitrate for every 1 mole of silver chromate. And then finally a mole to gram conversion using the molar mass of silver chromate. And this will give us a value of 0.488 grams of silver chromate. So what we've learned here is that if all the 0.5 grams of silver nitrate reacts, That means 0.488 grams of silver chromate can be produced. And so that means that is the theoretical yield. So the theoretical yield is 0.488 grams of silver chromate. That is if every bit of our silver nitrate actually reacts. If we were able to collect every single bit of the product and get it masked, that's how much we should have. So continuing with this same reaction, the same scenario, so we already have an answer to this first question. The theoretical yield, if 0.5 grams of silver nitrate reacts, that's our 0.488 grams of silver chromate. The second part of the question now is finding the percent yield. So if the reaction yields 0.455 grams of silver chromate, what is the percent yield? Well, this 0.455 grams is the actual yield. Okay, the word yield, I should probably have clarified. A yield is just what we collect, not like a yield on a roadside where you have to wait for other cars to go or something like this. The term yield just means what is produced. And so the reaction actually yields this 0.455 grams of silver chromate. That's our actual yield. We know what our theoretical yield is. That's the 0.488 grams calculated from before. We can use that to find our percent yield. So as we saw earlier, that's just the ratio of the actual to the theoretical yield. And as always, to turn it into a percentage, we multiply by 100. And that will give us 93.2% yield. Note your units here. Grams cancel. Percent. Remember, percent is actually a unitless value. You might say, well, the units are percent. Remember, percent just means out of 100 or per 100. It's a comparison of a ratio. So the unit is not grams percent, because the grams cancel. Is grams divided by grams would equal 1. All right, so there's an example of how we find a theoretical yield and a percent yield. Let's see another problem here. So now we'll consider this reaction between zinc and hydrochloric acid. You can see the balanced equation there. So the first question, if 25.0 grams of zinc are reacted with 23.2 grams of hydrochloric acid, what is the theoretical yield of zinc chloride, ZnCl2? So notice the difference between this problem and the last one is we are given two masses. We're given both the mass of the zinc and the hydrochloric acid, which that means we don't know what the limiting reactant is at the start. We don't know which of these two is going to limit how much zinc chloride can be produced. So we must determine the limiting reactant first. Even though the question does not say to do that, that's the only way we can determine the theoretical yield, because we don't know which of those reactants will limit our zinc chloride production. So to find our limiting reactant, like we saw from the last video, we need to find how much product, in this case zinc chloride, because it's asked us to find the theoretical yield of zinc chloride. I need to find how much zinc chloride can be produced from each of the reactants. So I'll just start with the zinc, and I'll do a gram, mole, gram, using the molar mass of zinc to convert from grams to moles, then my mole-to-mole ratio of 1 to 1, and then the molar mass of zinc chloride. This gives me 52.1 grams of zinc chloride if all the zinc reacts. Again, I don't know that it will yet because I don't know which reactant is limiting. I now do the same thing with the other reactant, the hydrochloric acid. I want to know what mass of zinc chloride can be produced from 23.2 grams of the HCl. So again, doing a gram, mole, gram problem, same as we've been doing for a while now, I get 43.4 grams of zinc chloride. So notice the hydrochloric acid can produce less zinc chloride than the zinc can, so my HCl is limiting, and thus my theoretical yield is the 43.4 grams of zinc chloride. Again, recall from the last video that once I get to that 43.4 grams of zinc chloride, I am out of hydrochloric acid. There's no more HCl left, and so the reaction stops, and I've reached my theoretical yield. All right, so the first part of the question we've answered. We said if 25 grams of zinc are reacted with 23.2 grams of HCl, what is the theoretical yield of zinc chloride? We determined from the last slide That's 43.4 grams of zinc chloride. The next question, calculate the percent yield if you collect 31.7 grams of the zinc chloride from the reaction. So now you've actually done the reaction, you collect your product, you get your 31.7 grams of zinc chloride. So again, our percent yield is just the actual yield divided by our theoretical yield. So 31.7 grams divided by 43.4 grams, and I then multiply that by 100 to turn it into a percentage, and I get 73.0% for my yield. All right, so a practice problem here where we combine all this stuff. I'll present the problem, give you a bit of direction, and then pause the video, try it yourself, and then once you've done it, go ahead and play the video and see how you did. All right, to perform the following reaction, you drop a copper wire weighing 1.62 grams in a solution containing 0.850 grams of silver nitrate. You can see the equation for the reaction here. Here's my copper, here's my silver nitrate, and my products here are copper 2 nitrate and silver. We're told you collect 0.262 grams of silver as a product. What is your percent yield? So this question here jumps right into asking you for your percent yield. So recognize this. We need to find the theoretical yield if we're going to find the percent yield. And because we don't know what the limiting reaction is, we also need to find that. So each of those things need to be found, even though we're not asked them specifically. In order to find a percent yield, we have to know what the limiting reactant is. We have to know what the theoretical yield is. That will allow us to find the percent yield. All right, so like we just said, find the percent yield. We must find the theoretical yield first. And to do that, we have to know the limiting reactant. So recognize the question tells us already what our actual yield of silver is. You collect 0.262 grams of silver. So I am going to find how much silver each of these reactants could produce. I want to know how much silver my 1.62 grams of copper could produce. I also want to know how much silver my 0.850 grams of silver nitrate could produce. So I'm just going to do a couple of gram, mole, grams here, converting from grams to moles of copper using the molar mass, then the mole to mole ratio of 2 to 1, silver to copper, and then the molar mass of silver. And this gives me 5.50 grams of silver. So if all of the copper reacts, I would get 5.5 grams of silver. Again, I don't know that it will yet because I don't know which reactant is limiting. I now do the same thing for the silver nitrate. I want to know how much silver I can get from 0.85 grams of silver nitrate. I convert from grams to moles using the molar mass, and then use my mole to mole ratio of 2 to 2, silver to silver nitrate, and then I can use the molar mass of silver to convert to grams, and that will give us 0.540 grams of silver. So note, I now know that silver nitrate is limiting because that can produce the least amount of silver. Because once I get to that 0.54 grams of silver, my silver nitrate has run out and I have none left over, so the reaction stops. So silver nitrate is limiting. The theoretical yield of silver is 0.540 grams because that's how much my limiting reactant can produce if we were able to collect it all. So now I can find my percent yield because I know my theoretical yield now. My theoretical yield is my 0.540 grams of silver. So to find the percent yield, I take my actual, that's the 0.262 grams that we were given in the initial text of the problem, and I divide by my theoretical yield of 0.54 grams, I multiply by 100, and I get 48.5% yield. And the problem's done. Now you may be wondering, why is it so low? Why isn't it closer to 100? Well, some reactions, just by their nature, they don't proceed very easily. In a lot of reactions, your limiting reactant actually will not be completely consumed just because there's a variety of reasons for it, but some might include the reaction just doesn't happen very easily at that temperature. The molecules and the particles have to run into each other in order for the reaction to actually happen. They don't do that in the right manner, and we'll learn more about that later in the year in a different unit. But having a low percent yield does not necessarily mean that you did the reaction poorly if you were actually doing this. Sometimes that's just the nature of the reaction where it just doesn't go to completion very easily. And so in this case, we get the 48.5% yield for our silver. All right, taking one last look at our learning goal and success criteria. This was the last video for learning goal 5.2. We have looked at how we can understand the limits of chemical reactions and the success criteria on this particular lesson. Success criterion C, I can define and determine the theoretical yield of a reaction, and success criterion D, I can determine the percent yield of a chemical reaction.